Good afternoon. This is problem 9.7b, one of the on your own questions from Module 9. And we're talking about measuring the concentration of substances based on their molarity. So molarity is a unit of concentration that tells how many moles there are of a substance per liter, for every liter. And the reason this is important, of course, we can do concentration as mass per volume, but if you think about chemical equations and everything that we're balancing, those chemical equations, those coefficients refer to moles or number of molecules. And so they don't relate the mass of any of the compounds that we're dealing with. So it's easier and more convenient for chemists to talk about the molarity of a substance when making a solution. And so in this particular problem, we want to know if we measure out 40.2 grams of sulfuric acid, which is H2SO4, and we dissolve that in water to make 6.8 liters of a solution, what is the molarity of that solution? How concentrated is that sulfuric acid, or in other words, how many moles are there in that 6.8 liters of solution? So when doing these kinds of problems, you want to first look at what is given. So we know our volume, it is going to be 6.8 liters, and the only other value that is given is the mass of sulfuric acid, which is 40.2 grams. We also know the equation for molarity. Okay, molarity is expressed as the number of moles divided by the number of liters. So then the question becomes, how many moles of sulfuric acid are there in that original 40.2 grams of sulfuric acid? We've weighed, we can't weigh out moles of sulfuric acid on a balance, but what we can determine is the mass. So we are given the mass, and what we need to know is how many moles of sulfuric acid are in this 40.2 gram sample of sulfuric acid. To do that, we must find the molar mass, and we spent a lot of time doing this in the last chapter. To find the molar mass, we must find the mass of one molecule of sulfuric acid first in atomic mass units, or AMU. So we look at sulfuric acid. There are 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. The atomic mass of 1 hydrogen is 1.01 AMU, the 1 sulfur is 32.1 AMU, and 1 oxygen is 16.0 AMU. And so we have to multiply hydrogen by 2 because we have 2 of those, multiply 32.1 by 1 because we only have 1 sulfur atom, and since we have 4 oxygen atoms, we must multiply that 16 by 4. And then, so once we determine the mass of each of those elements in our compound, then we add them up to find that our total mass of one molecule of sulfuric acid, or H2SO4, is 98.12 AMU. Now, when we add or subtract significant figures, we can only keep significant figures to the least precise measurement. And so in this case, we can only go out to the tenths position. So since this number in the hundredths position is a 2, that means this 1 will remain a 1. And so that we learn that if we measure out 98.1 grams of sulfuric acid, we know that in that 98.1 grams of sulfuric acid, we have exactly 1 mole of sulfuric acid. This becomes our conversion factor. Remember that 98.12 AMU does not equal 98.1 grams of sulfuric acid. This number just tells us how much we have to weigh out in grams in order to have 1 mole of sulfuric acid. So then we go back up to our original problem. We want to know how many moles of sulfuric acid are in our 40.2 gram sample. So we begin with our 40.2 grams sulfuric acid and put that over 1. We're going to do the factor label method. And since we want to cancel the grams, our number of grams that contain 1 mole will be in the denominator, and 1 mole of sulfuric acid will be in the numerator. And so essentially what we're doing is 40.2 grams of sulfuric acid divided by 98.1 grams of sulfuric acid will give us the number of moles in that sample. And what I like to do is to go ahead and write out a few extra digits. Remember, we always have to keep track of significant figures, but in order to do that we want to see the entire problem. So if you do this division on your calculator, you will end up with a number it's 0.409785. I think there's a few extra, but that's all you need here, moles of sulfuric acid. Both of these numbers have 3 significant figures, so we only need 3. So we look at our 409. Those are the only 3 significant figures. We want to go out to the hundredths place. But we need to know what to do with this 9, so we have to look at the number to the right. That number is a 7, so any number 5 or above means that we round that number to the left up 1. So that 9 becomes a 10. And your answer is 0.410 moles of sulfuric acid. So in this sample of 40.2 grams of sulfuric acid, there are 0.410 moles of sulfuric acid. And that makes sense, right? Because we have a little less than half of 98.1 grams. So you would expect in our samples, you would expect that we're going to have less than 1 mole of sulfuric acid there. The next thing we're going to do then is divide 0.410 moles divided by our volume, which is 6.8 liters. And then that will give us the molarity. And I think I have that on the next page. Yes. All right, and so here we have our molarity equation. Molarity represented by the capital letter M equals the number of moles divided by the number of liters. So we take our 0.410 moles of sulfuric acid and divide that by 6.8 liters. And again, in this case now, 6.8 only has 2 significant figures, so in our answer we need to have 2 significant figures. These first 2 zeros are not significant numbers, so we have to add a 0 on at the end, and so our answer is 0.060 molarity for concentration of the sulfuric acid. Okay, and that is it.